Ever wondered what's really going on inside a model like ChatGPT? Well, today we're pulling back the curtain on large language models, or LLMs, and we're going to be using some fantastic illustrations from the book Hands-on Large Language Models to see exactly how they tick.
It really does feel like magic, doesn't it? A machine that can write a poem. But how does it actually learn to do that? Behind all the complexity, there are some powerful, pretty intuitive ideas. And today, we're going to unpack them together.
All right, first up, the big idea. To really get our heads around this, we have to start with the absolute basics. At its very core, an LLM is just a really sophisticated text-in, text-out system. So, what does that actually mean in practice?
We've all done this, right? You give the model a prompt, and it generates a completion. But here's the key thing to grasp, the thing that underpins everything else. Its one and only goal is to predict the next most likely word. That's it. All the incredible things it can do just sort of emerge from that one simple task. So, this is the world LLMs live in, language AI. You've probably also heard it called natural language processing, or NLP. It's the whole field dedicated to teaching machines how to understand us. But to see how they got so incredibly good at it, we need to peek under the hood.
Okay, let's get into the engine room. How do these things actually work? Well, it all really boils down to this huge, fundamental shift in how they process language.
The early models, these things called RNNs, they worked kind of like trying to read a sentence through a tiny pinhole. They went one word at a time in a strict sequence. And as you can imagine, that makes it really hard to remember the beginning of a long sentence by the time you get to the end. The context just gets lost along the way. And then, boom, 2017. A single research paper comes out and just completely breaks that chain. It introduced an idea so powerful that it changed the entire game. An architecture that could see the whole picture, all at once.
And here it is, the transformer. Just look at how all the words are connected at the same time. This is a mechanism called attention, and it lets the model weigh the importance of every single word in relation to every other word. It can instantly understand the full context. It's brilliant.
Okay, but how does a machine actually read? It doesn't see words, it sees math. Text gets broken down into these little pieces called tokens. Each of those tokens is then converted into a long list of numbers, an embedding. The best way to think about it is like coordinates on a giant map of meaning. Words with similar meanings are located really close together on this map, and that's how the machine starts to understand relationships mathematically.
Right. So what puts the large in large language model? The answer? Scale, in both data and size. And it has been an absolute, total game changer.
This timeline really says it all. For years, progress was pretty steady. But just look at what happens after the transformer arrives in 2017. The number of breakthroughs just explodes. We go from GPT to GPT-3 and ChatGPT in just a few short years. The pace is just mind-boggling.
So what's driving this explosion? Scale, pure and simple. As this slide shows, the size of these models, which we measure in parameters, has gone completely vertical. You can think of parameters as all the little internal connections the model uses to learn. And the jump from GPT-1's 117 million to GPT-3's
175 billion is just staggering. It's this colossal scale that unlocked something nobody really expected: emergent abilities. Suddenly, these models weren't just predicting text. They could reason, they could follow incredibly complex instructions, and they could even write code.
So you've got this incredibly powerful engine. But how do you actually steer it to get what you want? Let's dive into the modern toolkit and see how it's done. It all starts with the prompt, right? But we've all been there. You ask for something, and the output you get is, well, it's not quite right. And that's where a really crucial skill comes in: prompt engineering. And here is one of the most powerful tricks in the book: chain of thought prompting. Now, it sounds complex, but just look at the slide. By simply adding the magic phrase, "let's think step by step," you force the model to show its work. And this one simple addition dramatically improves its ability to solve complex reasoning problems. It's incredible.
And to make this even more robust, you can use a method called self-consistency. You run the same step-by-step prompt multiple times, and as this visual shows, you basically let the different answers vote. It's a great way to weed out any incorrect lines of reasoning and find the most reliable result.
You know, it's not just about getting the right answer. Sometimes you need the answer in the right format. And this is where it gets really interesting. As this diagram shows, you can actually get an LLM to check its own work, creating a little loop where it refines its output until it perfectly matches the rules you've set.
And finally, you have a pretty fundamental choice to make. Do you use a proprietary black box model through a paid service because it's easy? Or do you go with an open model that you can run and modify yourself, which gives you full control and data privacy? It's really that classic trade-off between convenience and control.
Okay, we have covered a lot of ground. But what does all of this mean for you? Why does this matter? Let's bring it all together.
Ultimately, this isn't about memorizing a bunch of facts. The technology is going to change, and fast. The real goal is to build an intuition for how these systems think, because the core principles we've discussed today, they're the foundation for whatever comes next.
And that's the most exciting part. Building with these powerful tools isn't just for giant tech labs anymore. The walls have come down. Anyone with a good idea can now grab these tools and start building the future.
But as we build, there's a word of caution from the source, and it's known as Goodhart's Law. If you only train a student to pass one specific test, they might become great at that test, but terrible at everything else. The same is true for AI. Chasing a single benchmark score can actually make the model less capable overall.
And that leaves us with a final, pretty deep thought. As we design the next generation of AI, we really need to think about what we're measuring. Are we just testing for performance, or are we testing for genuine understanding? Thanks for joining me today.